Yeah, this does still need the area outside the box. This is all totally broken. I don't know why that wasn't showing up in the old code. Oh well. Where was R coming from? I don't remember what this code used to do. Oh, it's right out of here. Flat, no strong. Let me just do that. That's weird. It was using RMod 6, but this was using R5. That was kind of wrong. Must return a value. Don't know why VC6 reports this last. If that was a sufficient answer for everyone. Don't even know what the faint was in reaction to. So was my answer the same as Casey's? That's return num. All right, there. Finally got it all. It's got to be broken at the edges because of that thing. And I have bugs. Probably didn't initialize the tree. Yep, I didn't. I remember thinking about that. Add num trees equals 0. Let's move that down. Oops. This is doing an in-range check here, so how can this fail? Oh, because Z is totally bogus. Oh, why is Z totally bogus? Because I'm still using the old Z's that I no longer define. E plus tree height, because tree height is bogus because this is accessing outside. Yeah. I don't want to have to go back through and add all those +4s and -8s. Annoying. Do I only need it for... No, because I need the access height field. They all need it back. All this one doesn't, but these do. Actually, this one does, because that decides whether the... All right, I'll give it another 5 minutes. God damn it. God damn it. Should just go back and dig up the old code. Oh, all right. Yes, you're welcome to faint in all those cases. Somebody has a name that I can't even... really invisible on my... So let's see. What was I doing? I was adding 8s and 4s. Oh, this is so annoying. So dumb. I need to do this a different way. You can't do that offsetting trick with the 2D array though. So annoying. Because I really like that biome simplification. Is there a way I could avoid that? No, I don't think there's any way to avoid this. That whole thing I said was just totally wrong. Okay, and then these have to actually go -4, -4, +4, +4. Then these have to go. These don't have to do anything different. Who can use block type? When does block type get computed? This is not used anymore. Block type is not used anymore. All right. Biome is, but that's all there. I field int. All right. Is that all of them? I think it is. variable. Well, they all hit the asserts. X right is not equal X left plus treatment. Okay, so how far away did it get pushed? So X left versus EX. It got pushed 14 away. It's only 32 wide. Yeah. So, only thing we know for sure which is X left is less than equal to EX plus. Three-quarter size is 6 plus 6 plus 2 is 14. Right, so there could easily be a collision between those two. Wow. I hadn't realized that. Okay, so if they collide, then let's replace them with their average, because that's going to be the sort of smoothest distribution, right? I could just replace it with anywhere in between them. Trees 0, which is this a corner or an edge? Yeah, it's an edge, so I can afford a little computation here. We have a random number, we have n, yeah. So we can say add dot, add tree. We want to do stb lerp. We're going to do stb linear remap. We're going to remap n and 255, which we know ranges from 0 to 255. We're going to remap that to x left, x right. So it'll be somewhere between that and that. Let's just make this explicit so that people can even see what this is doing. Y mid equals that. So then we add the tree at x mid, y mid. Otherwise, we can add a tree in the middle potentially. Maybe never. Maybe that like never would happen. I don't know. Okay. That produces a float. Okay, so now we should just have trees along the edges. And they're mismatched along the edges, which means the height generation is not working correctly, which means my +4s are probably wrong. So we should just have trees randomly placed along the edges, but it should be along both edges. Did I forget to do the vertical edges? Did I only do the horizontals? Because I only see the horizontals here. But I do remember writing all the code. There's two trees that are too close together. Down in the center of the camera here. So obviously it didn't work. I have some bugs somewhere. On the other end, it maybe doesn't look that bad that they're that close together. Not very realistic, but no, this looks very realistic. So, so let me just at least figure out why only the horizontals are showing and not the verticals. That should be pretty easy. Well, so one possibility is that this logic is wrong. Oh, I don't swap those. Those are generated, and that might be causing the. That might actually be what's causing trees to be too close to each other. I still want to fix the height mismatch thing that's causing the weird tree shapes, but okay, those are clearly not 6 apart, are they? 1, 2, 1, 2, 3, 4, 1, 2. I can't quite tell. I think those are only 5 apart. The distance, center to center distance is 5 there. Yeah, there's 2 trees that are right against each other. So do I see both horizontal and vertical edges? No, I still only see horizontal edges. Why? Why? Okay, that should. Their coordinates are generated backwards, then I reverse them. 6, but they're the same. Matter. I don't know where. Oh, maybe these should say vertical. That might matter. Okay, so now we have this sort of grid of trees along the horizontals and the verticals, and we still have to write the code to generate the ones in the middle. As you can see, because of the way these chunks are pretty small, there isn't even that much space in the middle. So it may be that putting as many chunks along the edge as I do is actually wrong, and I want them sparser. I could, for example, only ever put one chunk along the edge. That might be smarter. And then when it generates the middle stuff, it will fill that in. Well, it can only get within. Yeah, maybe that's not right. It also doesn't seem to be displacing by 4. Seem to be only, well, yeah, all right, maybe they are. Although that's where there's too many. I'm not sure what's going on there. There's within 6. 1, 2, 3, 4, 5, 6, 7. No, those are 7 apart, so those are fine. But I saw some more. And I do still have this mismatched height field problem, which is expected. Because it doesn't. No, because I fixed that. Right, so why do I have that? Where did I lose the +4s? From my height field stuff. Height field, height lerp. We test height lerp. +4. Get the height field from +4. It all seems reasonable. BXBY. Was that possibly using the wrong? Might have been using the wrong thing. That might have been actually what caused the height mismatch. Seems like they all height match now. Though some of them have an oddly short height. I don't think the code is supposed to do that. Does the code do that? Height plus tree height, shift right run. Tree height is always at least 4. 2. Don't know. I don't understand that. In-game camera, I love it. How is it so smooth? I spent a little time on this for voxel render demo because I wanted that stuff to look nice, and I based it a little bit on watching some YouTube videos of Arma by Dyslexy from Shack Tactical, and sometimes, very rarely, when he dies or something, he will go and do a cinematic camera and show his guys who are like 80 guys playing co-op. He'll zoom around the map showing them, and I thought it looked pretty nice. The movement was really smooth, and he could turn and focus, and I have no idea what the controls are like for that. I need to actually go investigate because it does something that I don't do well, which it seems to handle well a range sizes, like being able to be up close and move slow and then be further away and move fast, and I don't have that in mind. But it was the thing that I used to give me guidance on how it should look. Wait, so do I ever have trees that are close together? I thought I still saw some trees close together somewhere. So that gave me my goal. Yeah, those are too close. I don't know why that is. Although, honestly, it does mean I could reduce the spacing to 5. It looks okay. Although those aren't the right trees yet. So the tree leaves would run together, but that's fine for tree leaves to run together. So what do I do? So yeah, I never did this on the chat because this was old code in SB voxel renderer. So, so I do a few things. One is, yeah, this doesn't handle the ranges as well as the ARMA stuff. So the way this works is that it's a sort of physicsy thing. So it's very acceleration based, and I had to learn how to drive it. So, right. So when I hold down a key, it applies acceleration. It's a fixed acceleration, constant acceleration while I'm holding it down. So, and then it has static and dynamic friction. So it has, it's called static and dynamic friction here, but that's not actually what it is. What it is there's a constant friction. So once I'm moving and I let go, when I'm moving at slow speeds, there's just a constant friction. It'll cause a constant deceleration. So it stops. But if I hold it down, I'll just keep accelerating. So there's another term that is dependent on velocity or velocity squared, I forget, that's tuned so that I hit some max speed. And at that max speed, then, you know, I'll accelerate smoothly and slowly decay to this. And of course, I'm in debug here, so it's being jerky when it generates the next chunk of terrain. And I actually compute that to be the right thing to hit some target max velocity, so I can explicitly set what max velocity I want, which is supposed to be 150 blocks per second, which is pretty fast. I don't know if it's actually, that's correct. I've never tested to see if that's what it actually hits. So, and the deceleration is more gradual. So then when I don't want to go at the full speed, like in the demos, what I have to do is pulse the keys. I have to go, oh, I want to go. So like when I was like, oh, let's see what this, when way back, I was like, let's see what this looks like inside of the Minecraft view height. Let's walking along at Minecraft speeds. I have to sit here, and you can hear, I have to sit here clicking the keys and sort of pulse width modulation to go at a moderate speed. I don't really have a good way to do that. And the longer I hold the keys down, the more I'll accelerate. And then the big thing that makes it actually smooth is the mouse look is not correct mouse look. So here we go. I'm going to turn, and I'm going to let go of the mouse. I've let go of the mouse. I've still let go of the mouse. I'm not touching the mouse. So it just smooths the mouse input, which is super annoying if you're in a game. You wouldn't want that at all. But to get a nice dubstep-happy demo with nice smooth movement everywhere, I just, yeah, do that. So that's just a spring system or something on the mouse movement, so that it's mouse look, and it's targeting, it's as if I'm doing input with regular mouse look. So I turn a certain amount, and it will eventually turn that amount. So you can kind of get a feel for it. And I can still suddenly change the direction because it's springy. So if I want to not suddenly change direction, I do have to slowly accelerate the mouse myself to get a smooth change. It's basically the same thing. If I want to have both fast and slow speeds of mouse direction changing, I have to kind of tweak the input myself. So if I want to really gradually turn here, I have to move the mouse really slowly. And if I want a fast turn, I move the mouse fast. And it's just that when I let go, and when I start it, it moves into it. Yeah, by happy, I meant friendly. I want a demo that is friendly for the crazy kind of stuff that is in that demo, and dubstep was just my cheesy way of saying that demo. But you're welcome to call that out as a crazy phrase, even if it's not really what I meant. But that's exactly how language works. So anyway, so this is pretty much working. Obviously, I have some problem with things being too close to each other, which was the whole system that this was supposed to avoid. And I'm not populating the center of the tiles yet, so you can't actually even tell that, you know, it's better than it was before, because now there's plenty of places where if you go down in a line, you probably never hit a trunk. That's just because there are too few trees. There's nothing actually stopping it from generating a trunk in this column, probably. Although it could be that the current way the math currently shakes out, it can. There are some that can't do in the edges and corners, but some particular columns that it would never generate in. Once there will be no constraints on the middle regions. They'll be able to generate anywhere in those middle regions, except if they're too close to edge tiles, but or corner corner trees. But there's no hard constraint, and so it should mean that any given column or row should be able to do it. And effectively, this should lead to, it's not as nice Poisson distribution as the Casey stuff, because these tiles are just too small to actually do that well. And so that was another concept I wanted to bring up, which is that this whole Wang tile strategy of doing these corners and then the edges, etc. There's no reason I actually have to do this on gen chunk size. I could do this on like a 128 by 128 thing. I could create 128 by 128 tiles that are for the patterns of trees. And when I go to generate a chunk, I pick whichever 128 by 128 tile it's in and generate that. And that would let me use much more freeform and a much better distribution, because the constraints would only apply in much more limited areas. The bigger tiles, because it's n squared for area, means most of the area would be more freeform. And I will do that for some things. In ZMC, the demo I showed the other time with the city, the main generate chunk is 256 by 256 because road things need to be much more structured, and so you need more structure around. So it does this 256 by 256, and it makes adjacent chunks roads meet along the edges by generating the edges first, which it does by generating the corners first in the same way. But at the same time, it also, very little of this was implemented, had this idea of mega tiles, which were, I forget now, I think 32 by 32 of those 256 by 256 tiles. The idea was then the mega tile would have these elevated roadways that the mega tile would decide where these big elevated roadways that slowly turned would go. And I'll do something like that in this demo at some point. I'll make some larger scale tile and, you know, maybe a K by K, say, and within each tile there'll be like one city or settlement or some small thing. Maybe draw roads from each settlement to each settlement. And we'll do that by just superimposing these tile grids at different scales and using the same corner edge style thing. And in an ideal, all fast enough to generate, we don't have to do any caching, that each chunk can regenerate all of the info about its tile and its meta tile and its trees and all that stuff from scratch, even though the neighbors are generating the exact same thing, just so you don't have to deal with, this might be the big fill, and now it's gotten inverted somehow. No. Just so you don't have to deal with that caching, because the existing caching is already enough of a mess that we really don't want to deal with adding more caching. All right, so that's it for tonight. And I will upload this to YouTube. And again, I will check out chat for a little bit. But there we go. This is maybe getting to the point now where next thing I'm going to have to do is fix that mesh leaking problem so that we actually start figuring out meshes, and I can actually drive for a while without running out of memory, because I know that's going to happen soon here. Other thing that you can see is you can get some sense, even though these trees are on a grid, this is giving us some sense of what it's like to have a sparser distribution of trees, and it's not bad. So it definitely would have some biomes that have a more sparse distribution of trees, which means the current corner and edge logic is really not a good idea. And maybe it would be better to switch to a larger tile, like I was talking about with 128 by 128 or something, where it can be driven by data, instead of here where I've just got this logic of, oh, at most 3 trees will fit, so let me hack in how you compute the 3 trees. Maybe I do want something more systematized so it can be used for different kinds of tree distributions. Or I could just, you know, have some rule for hiding, you know, suppressing some trees and just use the current layout, but that would be nice. All right, so anyway, all right, so that's it. Thanks for watching, and see you next time.